Let's take a look at parameterized constructors now. Now, if you remember the integer class that we started off with right at the beginning, what I've done is I have added a new constructor to this. Why is this a constructor? Again, it has the same name as the class and it has no return type. And I have defined this constructor like it should be in the public section. To be of good use, a constructor should always be declared in the public section. But it can be defined in the private section like we saw in the previous video. And you need to use a friend class in order to be able to use a constructor defined in the private section, but it is not much of a use when it comes to programming. So we'll stick to constructors defined in the public section. Now look at this. Here there are two new things to look at. The first thing is, if you remember the video where I had discussed default constructors or non-parameterized constructors, there I had declared the constructor inside the class and I had defined it outside. Okay, I think I have missed. Okay, just give me a minute. Let me close off the brace for the class. This is the brace for the class. Okay, this is my class. This is my class, and this is the constructor, of course. Now see, look at this. What I have done is I have defined the constructor this time in the class itself. Such definitions of constructors, whatever be the type of the constructor, whether it be a default constructor or a parameterized constructor as we see here, if the constructor is defined within the class, if the constructor is defined inside the class, such constructors are called inline constructors. Such constructors are called inline. Sorry about that. Let me change the pen. Such constructors are called inline constructors. Okay. Just like we have inline functions, we can also have inline constructors. So such constructors are called inline constructors. Constructors defined within the class itself are called inline constructors. This was point number one. Point number two is, this constructor is a parameterized constructor. Why is it a parameterized constructor? It is a parameterized constructor because look at its function signature. The function signature, which is delimited by opening parentheses and closing parentheses, has two arguments. So remember, if a constructor takes one or more arguments, whatever be the type of the argument, if a constructor takes one or more arguments, such constructors are called parameterized constructors. Okay. So this is a parameterized constructor. Now, let's assume that we are creating an object I1 of class integer, and this is how you would call, or you would create an object. You would create an object having the parameterized constructor. So parameterized constructors will help you to pass values of your own. See, in default constructors, what you had was, since there was no provision of passing arguments, you had to assign some fixed value all the time. Here you can play around with the values. So I'm creating an object I1, and in the first case I'm passing 100, 0 and 100. So 0 will be passed to X and 100 will be passed to Y. Now when I'm creating another object I2, let's say in place of passing 0 and 100, I can pass 10 and 100. So I can play around with the values. It's not that all objects will have the same values for all data members at all times. Here, different objects can have different values or the same values. Now look at the type of declarations here. See, here also I'm creating an object. The object is I1, passing values 0 and 100 to its data members M and N respectively. So my data members here are M and N. So 0 will go to M and 100 will go to N. Why? Because 0 will first be copied to X, 100 will first be copied to Y, and then M will get the value of X. That means M will get the value of 0, which is copied from here, and 100, which is copied from here, will be given to N. So I1, which has its own copy of the data members M and N, get the values 0 and 100. Now this way I can invoke my parameterized constructor, and such an invocation is known as an implicit invocation. This is how you would implicitly invoke a parameterized constructor. Although you are not invoking the constructor as such, remember constructors are automatically invoked, you are implicitly calling or implicitly creating the object which is leading to the parameterized constructor being invoked. Here you are explicitly creating the object leading to the parameterized constructor being invoked. See, both these cases will invoke the parameterized constructor automatically. But what is the difference? You can see the difference in the syntax. Now, which one would you go for? Personally, I would recommend the implicit call because it is a lot more compact and a lot easier to understand compared to the explicit call. But it's good to know about them. It's good to know which is the implicit call and which is the explicit call, like you can see here. So I hope you have understood, right? So the moment I create I1, what happens is, I'll just extend this point a bit. I1 gets its own copy of the data members M and N, right? Similarly, when I create the object I2, it will also get its own copy of M and N. So since 0 is passed to X and 100 is passed to Y, for I1, I'll have 0 for M and 100 for N. And since 10 is passed to X and 100 is passed to Y, I'll get 10 for M of I2 and 100 for N of I2. So I hope you have understood how a parameterized constructor works. Okay, now let me move on to the fact that how a parameterized constructor can be used to take in more different types of arguments. Okay, let's see another example of parameterized constructor. Now look at this. Parameters of a constructor can be of any type except that of the class to which it belongs. So I've taken two examples. Let's see this first example. So I have a class called A. In the public section, I have declared a constructor. I have only declared a constructor. Only through the declaration you can understand this point. Okay, the definition is not required. The declaration is enough. So from the declaration you can understand that this constructor A is taking an argument which is of the type of the class itself. What is the type of the argument? The type of the argument is the class type argument. Okay, if you are unable to understand this, here I have only mentioned the data type. Remember, when I am declaring a function, so since constructor is a special member function, the rules of function apply to constructors as well. So whenever I am declaring a function, the data type of the arguments is compulsory, but the name of the arguments is optional. When I am declaring a function, the data type of the arguments is compulsory, but the name of the arguments is optional. Here, that's why I have only shown the data type, which is that of the class itself. But still, if you are unable to understand, if you are confused, writing only A and writing A, okay, sorry about that, and writing A obj means the same thing. Here I have also written the type of the, also the name of the argument. This is the type of the argument. What is the type of the argument? Same as the class name. That means the type of this argument is same as that of the class type. What is written here? That parameters of a constructor can be of any type except that of the class to which it belongs. Since this constructor belongs to class A, it cannot take in an argument of class A. So that's why, since obj, what is the type of obj? The type of obj is A itself. Now what is A? A is the name of the class to which this constructor belongs. Such arguments are not allowed. So this is illegal, and if you try to do this, you will get a compile time error. And what is allowed? What is allowed is a constructor is allowed to accept a reference to its own class as the parameter. See, this constructor A is accepting a reference to its own class. See, it's accepting a reference. How am I saying that it's accepting a reference? Because it's written ampersand. Ampersand, like the data type followed by ampersand, means that it is a reference type. So a constructor is allowed to accept reference type of the class itself. That is allowed, but it cannot accept a type of the class itself. It can accept a reference to the class, but it cannot accept the type directly. Okay, so this is what you need to keep in mind for a parameterized constructor. But remember, from parameterized constructor, we have come to a new constructor. And what is this new constructor called? This new constructor is called a copy constructor. And what will this copy constructor do? This copy constructor will accept a reference to the class of which the constructor is a part. Now in the next video, we'll discuss about copy constructors in detail. I hope this helps. Thank you.